In this section, we will discuss RAID level 5, which is also called a stripe set with parity. As you know, RAID stands for Redundant Array of Integrated Disks. And we have different types of RAIDs. RAID level 0 is striping, which provides increased performance, and RAID level 1 is mirroring, which provides fault tolerance. But RAID level 5 provides both fault tolerance and increased performance. So let's look at RAID level 5, which is also called a stripe set with parity. A stripe set, as you know, is where the operating system writes to multiple hard disks simultaneously. If we take the number 7 here, which is 5 zeros and 3 ones, instead of being written to one disk, it is written to 8 disks simultaneously, so therefore it is saved to the disk or retrieved from the disk 8 times faster. Each bit is written to a separate disk. With stripe set with parity is where we add a 9th disk to this 8-disk set. We add a 9th disk, and that holds the parity bit. So now we have to step back and discuss the concept of parity. And parity was first used in telecommunications between computers. We have a situation where one computer is sending the number 7 to another computer, which is 5 zeros and 3 ones. Now, what if one of these bits gets accidentally flipped in transmission? Then the receiving computer will not receive a 7, it will receive a 6. But the receiving computer will not know there has been an error in transmission. This is why we use parity. What we do is for each 8-bit byte, we add a 9th bit, or should I say the computer's operating system adds a 9th bit called the parity bit. And the parity bit is set to 0 or 1. The parity bit is set to 0 or 1 such that when we add up all 9 bits together, we get an even number of ones. The parity bit is set to 0 or 1 such that when all the ones are added up, we get an even number of ones. So in this situation, we had an odd number of ones, so the parity bit is set to 1 to give us an even number of ones. Here are the examples. If one computer is going to send the number 7 to another computer, which is 3 ones, the parity bit is set to 1, so we always have an even number of ones. If one computer is going to send the number 3 to another computer, which is represented as 2 ones, then the parity bit is set to 0, so we will always have an even number of ones. If one computer is sending the number 1 to another computer, which is 7 zeros and a 1, then the parity bit is set to 1, so we always have an even number of ones. So when one computer sends data to another computer, if one of those bits gets accidentally flipped in transmission, how will the receiving computer know that one of the bits has been accidentally flipped in transmission? Well, the receiving computer will receive an odd number of ones, and then that indicates that there has been an error, because it should only send an even number of ones. And when it indicates that there's an error, then the receiving computer sends a negative acknowledgement to the sending computer, which resends. This is parity in telecommunications. Now, let's look at parity in RAID level 5, a stripe set with parity. We have a stripe set that goes across 8 disks, and the 8 bits in the 8-bit byte that represent the number 7, each bit is saved to a separate disk, and the reason they do that is so it will read and write faster. But for fault tolerance, what we do is we add a 9th disk called a parity disk, and that includes the parity bit. And as you know, the parity bit is set to 0 or 1 such that when we take all 9 bits together, we will always get an even number of 1s. This parity bit is set to 1. So now if a disk fails, and then we put in a new disk and we select regenerate, how does it know whether to put a 1 or a 0 on this new disk that we are trying to regenerate? Well, if you always have an even number of 1s in the 9 bits, and we already have an odd number of 1s, and this bit has to be a 1, so we always get an even number of 1s. We regenerate the failed disk based upon parity. So, RAID level 5 is a striped set with parity. It provides not only increased performance, but fault tolerance as well. RAID level 5 striped set with parity gives us fault tolerance and increased performance, but it can be a little bit complicated to understand. In summary, RAID level 0 is a striped set. RAID level 1 is mirroring. RAID level 0 plus 1 is a mirrored stripe set, but it's an awfully expensive way to go. And RAID level 5 is a stripe set with parity. And this concludes our section on RAID level 5.